Now introducing limits in L'Hopital's rule with
Ari!
Sarah and Claire.
Hello, it's your host Ari for evaluating limits to a number. Here are your steps. First, you want to plug in all a values for x and then step 2, evaluate. So for this problem, your a would be 2. So if you plug in 2, you get 2 squared minus 4 over 2 minus 2, which equals out to 0 over 0, which is undefined, which is sad face because it doesn't work. So you're going to have to do some algebra and factor the top and the bottom, but in this case, you only have to factor the top. So it goes x minus 2, x plus 2, over x minus 2, and then x minus 2 cancel out. And that leaves you with x plus 2, plug in the a, which equals 4. It works. Alright, so for example 2, your a value is 0, and if you plug that into the equation, you can see that it will be undefined once again. So you want to factor. So for the top, you just take out a 2x, which leaves 2x minus 1. And then for the bottom, take out an x, leaves 3x squared plus 5. Then you can cancel out the x's, which leaves you with 2 times 2x minus 1 over 3x squared plus 5. Then you can plug in your 0, which leaves you with negative 2 over 5, which works. Next, we're going to be learning about evaluating limits to infinity. The most important thing to look at when evaluating limits are the powers. Alright, so for the first example, we are approaching infinity. So when you are looking at this, you just need to worry about the highest power. So you can just ignore the rest of this. And as you can see, these two have the highest powers, but they also are both x squared. So when the powers are the same, you just worry about the coefficients, which means this equals 3/4. Okay, for example 2, we are approaching negative infinity this time. So, once again, you can just cross out everything that doesn't have the highest power, and these two are have the highest powers. So, this time they aren't the same, as you can see, they are 4x fifth, 10x fourth, and the top has the highest power, which, if you look at our rules, you can see that when the power is greater on the top, it's either negative or positive infinity, which the answer is always the limit. So in this case, it's negative infinity.
So I'm Sarah. I will be teaching you about L'Hopital's rule, and it completely changes the game of what you thought were true about limits. So if you're taking the limit of f of x over g of x as it approaches a, and it equals either 0 over 0 or infinity over infinity, then you will do L'Hopital's rule. And that is, you take the derivative of the top and bottom separately. Okay, so that means the limit would then equal f prime of x over g prime of x. So we are taking the limit of x minus 2 over x squared minus 4, and if we evaluated this like a normal limit, it would come out to 0 over 0. which is how you know to start doing L'Hopital's rule. So what you do is you just take the derivative of the top, which is 1, and the derivative of the bottom, which is 2x. And then after that, you can plug in your a value, which makes the answer 1/4. So for this problem, we are taking the limit as x approaches infinity. And if we solve it like a normal limit, just plugging it in, you would get infinity over infinity, which is not good, bad. So you have to take the derivative of the top and the bottom. So if you do that, it'll be 2e to the 2x over 3x squared, which still will give you this, which is still not good. So you take the derivative again. So then it'll be 4e to the 2x over 6x, which again will give you this, which is still not good. And then if you take the derivative one more time, you will get 8e to the 2x over 6. And you can now plug in your initial value again, which will give you infinity over 6, giving you the answer of infinity.